Okay, so for today, we already moved to the number seventh algorithm, and it is the classification algorithm that we are going to learn today. And it is called k-nearest neighborhood. And we are going to do that by sklearn. Okay, so obviously this is basically talking about if you have a point and we're trying to find the information of this point by its neighbors. And again, this k, just like k-means, it is some hyperparameter that we can adjust to change the model. So this is a particular parameter that we are going to talk about later. So the idea is like the following. Really, this model is quite simple. The main philosophy is just one sentence. Okay, so suppose you have one point, and there are some points, neighbors nearby. By neighbor just means the points nearby, and the neighbors nearby has its own different categories. And so the main philosophy is let the neighbors decide to vote for the decision. Okay, so let the neighbors. And how many neighbors? Let the k nearest neighbors vote for the classes. Okay, so there are two highlights. You see, the first one, I'm going to X what is my category what is my category. I'm going to X my neighbors to decide what is my category. But they might have the different opinion, so I will ask them to vote. So in the end, if the majority decide that my points is actually a photo of a cat, then I am a photo of a cat. If the majority of the my neighbors decide that, okay, I am a photo of a dog, then I'm a photo of the dog. And that's just a simple philosophy of this algorithm. Okay, so in terms of the picture, that will be more clear, and let me start over. Let's say we have some data points like this, and somehow I draw that with a triangle, some markers there, just to indicate that there are two different categories. You may imagine that the triangle is the image of a cat, and the round circle is the image of a dog. Okay, so I have some data points like this. Okay, so this is the data, and maybe there are lots more, but I'm just trying to illustrate some of the points. Now the question is, suppose there is new data coming in, and we don't know whether this guy is a dog or a cat. It belongs to triangle or belong to a circle. And then this k-nearest neighborhood classifier will make a decision by the following rule. Okay, so for example, if I say k is equal to 3, then I will look for 3 neighbors that is closest to myself, which is this one, and this one. And so when k equal to 3, I'm basically looking at all the points nearby, and these 3 points is the 3 closest neighbor nearby me. Okay, and then you will see that the vote is equal to two triangles. Okay, I'm just going to write numbers. Two triangles and one circle. Okay, so in the end, it decides that this new point is going to be a triangle. And that's an easy philosophy, right? Whether I'm a triangle or a circle, I'm going to ask my neighbors to vote, and I will follow the majority rule, 就多数决, follow the majority rule to decide what is my category. And somehow this K can change the decision a little bit. Depends on how many Ks you are looking for. Sometimes the K will change the outcome. If you decide that K is equal to 7, for example, okay, and you will see that 1, 2, 3, 4, 5, 6, 7, these are all the points nearby. And when K is equal to 7, then the votes is a bit different. You have 3 triangles and 4 circles. And this tells us that in this case, we are going to say the new point is equal to a triangle, belong to the category of the triangle. So we will define K beforehand, and then use K to do the training. So there are a few points. K is decided beforehand. And we call this kind of parameter as the hyperparameter. Hyperparameters are the parameters that you send to the model, and this is in contrast to the parameters that you are going to train inside the model. Okay, for example, k-means, the k in k-means, and what else? The fit intercept, whether it is true or false, these are called hyperparameter. You decide these parameters and then you send to the model, and other parameters, those are the parameters that is going to be trained during the model. Okay, so K is decided beforehand. The second thing is when we talk about the training for K and N, okay, this abbreviation, people usually call that as K and N. Okay, the training of K and N is just to store all the data. So even though you have like a gigantic data, and the training part is going to be very fast because you just read the data and then save that into the memory. That's all. But in contrast, the training part, you have to find the neighbors. You have to find the shortest neighbors. It looks easy for human, but in computer you have to calculate. You have to calculate all the distances, and then you realize, okay, these are the 3 closest neighbor, and these are the 7 closest neighbor. So basically, you have to do the pairwise distance and then do the sorting. So the prediction part actually takes longer. Okay, So you will see this kind of behavior if the data is getting bigger and bigger. And actually, although this is a simple algorithm, KNN is not super efficient. When the data comes up to a certain scale, then it will take a while. It will take a long time. And even worse, usually we will believe that when we have more data, then it will be more accurate. And so we want to collect as much data as possible, right? And that's the general philosophy. But KNN will set a limit that if you have too much data, then I'm not able to do the prediction because it is going to be too huge. So it is kind of a dilemma for KNN. KNN is very effective, but in some sense, it cannot be very efficient. Okay. The last part, just kind of a side note, KNN has nothing to do with something like a artificial neural network, convolutional neural network, recurrence neural network, and that kind of thing. This NN is different from this NN. Okay, so this KNN is nothing to do with this one. Okay, so that's the general philosophy, and that's pretty much all you need to know about KNN. It is the simple one. So let's talk about the syntax, and then talk about the syntax, and then talk about the parameters, and I will show you some examples. Since I'm here, I'm just going to copy that. So for KNN in sklearn, we are going to do something like this. Okay, I believe this is much better than my handwriting, but we still have time to read it. Okay, so KNN store its model in this module called neighbors. From sklearn.neighbors, we are going to load these KNN classifiers. And then we can select the model with the specific parameters. These are the hyperparameters. Then do the training, do the prediction. And as mentioned, this is the supervised learning. So I'm going to use one set of the training model, training data, and then I'm going to use a new set of the testing data. Okay, so pretty much that's the same, and all you need to know is where to load this model. And the parameters are also easy. Pretty much there is only one, which is n neighbors. And I'm going to just call that as k. K is the number of neighbors that we are going to look for. We are going to look for k nearest neighbors and then make them vote. And somehow there is something else called algorithm. This is somehow you don't have to take care of that. It set up a different algorithm to achieve this one. The reason is that when we calculate the pairwise distance, and it will take a lot of time. If the data is huge, then the pairwise distance to calculate that will take a lot of time. So there are actually other algorithms called probably ball tree and KD tree. But we are not going to dive into that. Those are just the two famous algorithms for finding the nearest neighbors. And there is also a brute force. 就是暴力, okay? So these are ways to find the pairwise distance. And when the default is auto, by that it means when it will decide based on the size of your data and the dimension, it will decide whether to use the ball tree or use the KD tree. And brute is just something that they set it up kind of for fun to make sure everything is okay. In fact, this brute force algorithm is the same, pretty much the same as the DIST matrix. Let me put it this way. Okay, very similar to the DIST matrix that we have defined. So it is not going to be efficient, but it is going to work. Finally, there is only one attribute, that's the classes, and it is the label. Okay, so that's how it works, and it should be one of the easiest algorithms that we have learned. Okay. So if you have any questions, please feel free to stop me at any time. Now, I'm going to talk about one common mistake, and after that, I will show you some examples, and we are done for the first hour. This is one common mistake, particularly for k and n. And this is when k is equal to 1, which means that you only ask one of your neighbors. You kind of trust whatever whatever your neighbor says, and that sounds not a good idea. And secondly, usually for supervised training, you have to have the training data and the testing data. But if you don't do this, you kind of use the training data. You use the testing data to evaluate the performance of the model. Sorry, let me start over. You have the training data, and usually the model has a good performance on this one. And you usually have another set of data, testing data. And the testing data, you have to look at the testing data to evaluate how good is your model, right? And if unfortunately you use your training data to evaluate your own model, then it's likely to be very biased. And here is one of the example. So what's going on is if you have a data X and along with the label Y, and after the KNN, you will train a model. And with k equal to 1, let's say k equal to 1, okay? But then you can do the testing, but if you don't do the new testing data, you say x is the same as the testing data is the same as the x, and then you use the model to do the predict. Then you will get a new label. It's called y new. And you will realize if you do this, regardless the data you have, you always have y equal to y new, which means 100% accuracy. And this is just not something surprising. If you sit down and think again, what happens here is you only ask for the closest neighbor. And then, which means that when you are training the model already knows all the answers, right? And now you use the same question to ask the model. Say, for example, this is x10. There's an x10, and the model is trained by these things. Now, x10, if you ask what is the closest neighbor in x, then it must be x10, right? So x10 knows the nearest neighbor is x10 itself, and fortunately or unfortunately, the model knows the answer also. So it will just output exactly the correct answer as in here. So all the time you are going to get exactly the same thing. Y and Y new, they are going to do the same thing, and you got 100% accuracy. And it just means nothing. It just means that you set the model somehow in a kind of ideal way, unrealistic way, and so that everything is too good. And it doesn't mean that your model is perfect. Okay? So I will show you one example later. But since I'm able to record all the screen, then let me try to type something and give you some examples. Let me take out everything and start over. Now this is KNN with sklearn, and let's run a few models, import some of the libraries, and try to copy this part, which we are going to use later. And now I'm going to focus on exercise 1. Let me put it here and comment it out for a while. And then we have some data here. The first thing we can do is try to print what is the shape of X. It is 200 by 2, so you can look at that. You can view that as 200 samples in two-dimensional feature space. And so let's try to plot that. And then color is equal to Y. Y is something that is just between 0 and 1. So we have seen this data before, right? We have seen this data before. Now let's do the training. You see, from sklearn, neighbors import this model and set model equal to this classifier. Let's take the default setting, okay? And we can do the model.fit. And now we have X and Y, we are able to train the model. So this part is the training. But now we don't have the testing data, right? So what I'm going to do is try to randomly put a lot of points on this area, okay? It's between, say, -5 to 5, -5 to 5. That's to make it easier. Let's try to take the X test as the following. X test is equal to np.random.rand. And this RAND function will take a uniform kind of randomly pick 1 points between 0 and 1. Okay, and so I'm going to take, say, 1,000 points by 2. I'm going to take a lot of arrays, a lot of numbers between 0 and 1. And because I want it to be between -5 to 5, I want to enlarge that by 10 and minus 5. Okay, so this is just some data, random points in the rectangle. Say X is between -5 to 5, and same for Y. Okay, and now we have all these points, then we are able to do the X test. Now we have the X test, and then use the model.predict to get the Y new. Okay, that should be good. And in the end, we want to see how does the prediction. We can plot all these x tests. And then set c equal to y new. Okay, so basically doing the same thing, but using the new set of data. But somehow I want to distinguish the testing data and the original data. So I'm going to set the size a bit smaller, say 10, and set the color. No, I'm not going to set the color, but I can set alpha equal to 10%, I would say. 0.1 actually. Okay, it seems a bit too light. Let me do it a bit darker. Okay, so you will see that the bigger one, those are the original data, and the small dots, it is like this. And let me make it a bit bigger. Okay, so basically, if you see this point, it is going to ask k neighbors nearby that, maybe this one, this one, this one, and make them to vote. And similarly, if you pick one point here, it is going to ask the k nearest neighbors, ask them to vote. It's likely to be yellow. Something in between. This is not going to be a straight line. I can run this several times. You will see that sometimes it is quite curvy. And it is not even a good curve. It is not smooth curve. It is I think it is going to be something like some segments, 一些折线. Okay, so this will show you how does the KNN work. And let me copy all this to Discord. Example of KNN. I just realized I can copy and paste the code, and they will be friendlier for you. And then I will paste the image later. Copy image, and then this is the outcome that I had. Okay, so that's the first example. It can help you to make the classification. Now, let's move on to the next one, and then I will give the time back to you. Okay, now exercise 2, you will see that it is another set of data. And you can read the data by iris.description. And it will tell you a lot of information here. But all you need to know is what is x and what is y. So x.shape, it is 150, and it has 4 dimensions. And if you look at y, it is like this. And you can see y.unique. And the unique elements here, non-repeated elements are 0 and 1 and 2. So that means y is the categories, labels the categories for x. Okay. Indeed, if you just look at y, it's quite clear. There are about 50 zeros, 50 ones, and 50 twos. So this is the super clean data. But anyway, we are going to do the training as usual. Let's copy the code here. Okay, so again, we load these things, and I set k equal to 1. Okay, n neighbor equal to 1. And then I do the fit, and I'm going to do somehow stupid, as I mentioned. Not a good idea. I mean, use X for testing. Okay, it is not a good idea, but I'm just trying to illustrate this idea. Okay, so I'm going to use X, and then X will generate what is Y new. So you will see that it finished the training, and you can check whether Y equal to Y new. then it's exactly the same. Everything is the same. And there is actually, if you see later on, number 2b. 2b tells you that you can use the accuracy score. Okay, so from sklearn, there is a matrix. Matrix just means a lot of things that you can measure how good is the model. And there is one function called accuracy score. Now use the accuracy score, and there are two labels. One of them is the correct label, and the other is the predicted label. So you just put them in, and then you will generate the percentage, and you will see that okay, the accuracy is 100%, which is too good to be true. And indeed, there are some mistakes here. So again, I'm going to copy this code to the Discord. This example of k equal to 1 and training equal to testing. Okay, so I'll stop recording here.